We look up at the night sky and see a quiet, glittering expanse, but that peace is an illusion. For the first few 100 million years after the Big Bang, the universe was a dark, perfectly smooth, featureless sea of hydrogen and helium. Then something shifted. A microscopic fluctuation in density broke that perfect uniformity. It was a disturbance so small it would barely register, yet it was enough to give gravity the leverage it needed to start pulling matter together into massive clouds. That single disruption turned gravity into the ultimate cosmic sculptor. It ended the dark ages of the universe and set the stage for the most violent physical battlegrounds in existence. Every star you see is an active war zone. Beneath that glowing surface is a vicious, ongoing conflict between two opposing forces pushing against each other with unimaginable strength. On one side is gravity, relentlessly attempting to crush the star inward under its own massive weight. On the other side is nuclear fusion, a continuous chain of thermonuclear explosions generating the immense outward pressure required to keep the star from collapsing. As a massive star ages, it exhausts its hydrogen and turns to burning heavier elements to stay alive. The core begins fusing helium, then carbon and oxygen. With each new element, the reaction burns exponentially faster, layering the core like an onion as the star desperately fights off gravity. Eventually, this frantic synthesis reaches a fatal turning point. The core begins fusing silicon, which produces iron and nickel. Unlike lighter elements, fusing iron does not release energy, it absorbs it. The iron acts like a sponge, soaking up the thermal energy that was generating the star's outward pressure. In an instant, the fusion engine stalls. Without that outward force, gravity wins. In a fraction of a second, the entire mass of the star is crushed inward into the core, instantly rebounding into one of the most violent events in the cosmos, a supernova. Smaller stars like our Sun won't go out with such a massive detonation. They quietly surrender to gravity over billions of years, shedding their outer layers and slowly fading into cold white dwarfs. Gravity always wins the final battle. Yet those massive stellar defeats scattered heavy elements across the void, the exact same materials required to build rocky planets and biological life. The universe has been churning for nearly 14 billion years. In contrast, modern human civilization has only existed for about 200,000. We are incredibly late arrivals. When we look out at the trillions of galaxies, each packed with billions of stars, the mathematical probability of finding other biological entities seems almost certain, yet we see nothing. This leaves us with a few distinct possibilities. The first is that life on Earth is an anomaly, a freak, isolated accident of chemistry that simply never happened anywhere else. The second possibility is that biological life is abundant across the cosmos, but we are permanently isolated from each other by the insurmountable limitations of space, time, and the speed of light. The distances are just too vast to ever cross. The third is that life didn't originate here at all, but was deliberately seated on this planet by a highly advanced ancient intelligence. Despite the infinite amount of planetary real estate out there, we have yet to find a single neighbor. That deafening silence remains one of humanity's deepest existential terrors. Theoretical physicist Stephen Hawking harbored very specific warnings about trying to end that silence. He believed that searching for extraterrestrial life was a massive risk. His logic was practical. Any civilization capable of crossing deep space would likely be millions of years ahead of us. They might not be benevolent explorers, but nomadic conquerors moving from system to system, seeking to harvest resources from weaker planets. That fear of a superior power in the sky is deeply rooted in our history. Thousands of years ago, ancient civilizations were already looking up, desperately seeking connection and attempting to document their relationship with the stars. We see this obsession built into their architecture. They engineered massive structures with unexplainable precision, aligning thousands of tons of stone to intersect with celestial paths. The Great Pyramids, for example, were designed to mirror the position of the three central stars in the Orion constellation. We have always tried to signal the heavens, but broadcasting our existence, whether by stacking millions of tons of limestone or beaming radio waves into the void, is a massive gamble. We might find cosmic brotherhood, or we might be inviting our own destruction. Yet there is a force even more persistent than gravity. It doesn't crush or detonate, it simply outlasts. Time is slowly dismantling the entire universe piece by piece. Which brings us to the ultimate philosophical question. If strict physical laws dictate the exact moment a star will collapse, is the human future also following a predetermined script? To explore this, physicists use a quantum framework known as Schrödinger's cat. Imagine a cat inside a sealed box containing a radioactive mechanism. Until you open the box, you cannot know if the mechanism has triggered. The cat's future exists in overlapping probability, simultaneously alive and dead. The outcome remains undetermined until the box opens. It is the act of observation that forces the universe to choose, collapsing probability into a single solid reality. If we view our own lives through this lens, the future becomes a collection of possibilities rather than a fixed path. This suggests that the next chapter of our lives doesn't exist until our actions pull it into the present. Gravity will eventually claim the stars, and time will eventually fade the universe into silence. But those forces only dictate how the physical story ends. Right now, through human consciousness, we are literally the universe experiencing itself in the present moment. Gravity and time are the final arbiters of the physical world. But until then, we are the ones observing, deciding, and writing the script.